And then this will be posted on YouTube later today. All right, so question 6 deals with the fluid replacement type of question. There's a variety of ways to answer this question, but I will start off by just showing you like the more direct way and how I would recommend that you do it, because if you see a question like this, it'll be worded pretty much the same. You just need to make sure you know and identify which is the actual urine output, what is the theoretical urine output, and what is the replacement volume. And as long as you know that, you should be able to answer any of these types of questions. Now, before I get into this, I just want to remind you, and I said this on the review I did on Tuesday, when you're doing basic unit conversions, so like milligrams to grams or micrograms to milligrams, you do not round those answers, okay? You do not round those answers. So like for this number 1, the answer to that is 0.75. You don't round that to 0.8. You don't round that to 1. You leave it as 0.75. This becomes 0.125. That is the answer. Do not round it to 0.13. You do not round basic unit conversions, okay? The only time that you should be rounding when it comes to like these like simple, straightforward, like kind of basic unit conversion type questions are where you're converting from into or out of the metric system. So here we're going from 131 pounds to kilograms. What that answer, and I specifically gave you that answer for practice, or that question for practice, because you have to do some rounding. And then I think you'll see that the answer comes out to, you know, something 0.454545. You do round the answer to 0.5 for these questions, okay? Just wanted to touch base on that. And then if you need to review, I have written up the rounding rules are listed here in the review. And it should be in your packet. It's on the OneDrive you have access to. So if you have questions, let me know. But I think that should be pretty straightforward. And it's the similar rounding rules that you had in your first semester. So, all right. So for this question, I need to identify a couple of things. I need to identify this is the potential urine output, the 125 milliliters. This is the replacement volume, and then this is what was actually collected by the patient, the 500 milliliters. So that's what we're paying attention to. So I'm going to write that out. I'm going to go to my screen here. And so my actual out was the 500 milliliters. My potential out was 125 milliliters. And then my replacement in, we'll just say the replacement volume, was it 40 milliliters, I believe. Okay. So what will change on these types of questions will be what these say. So the actual output might be only 50 milliliters. It might be 1,500 milliliters. Your potential output might change to for every 250 milliliters lost. This might increase to 120 milliliter replacement volume. The volumes are going to ebb and flow. In all reality, this question kind of seems baffling because the 40 milliliters is representative to, or that seems like a small quantity over 4 hours. You know, that's like a shot of water. So some of these just seem like they might not be practical. Anyways, so my actual output, and what I did, and just to kind of streamline this, is if you follow this formula, you should be able to get this question right every single time. Okay, so I'm going to take my actual output of 500 milliliters. I'm going to divide it by the potential output of the 125 milliliters, and then I'm going to multiply by my replacement volume. And if you do that every single time, you will get the right answer. And I believe is the answer 160 milliliters. That seems right to me. Assuming it was a 40 milliliter replacement volume. So I'm going to double check that. Yeah, 40. Okay. So that was number 6. And then I was just told 14 was referring to the next review session. So we don't need to worry about that for the 130 review. All right. Now, I believe, if I'm not mistaken, 16 and 17 are going to be relative to the new stuff that you guys are doing, the flow rates. So flow rates is new for you guys for the 130 class. And so I'm going to give you some notes on flow rate, and then we'll answer these questions, and I'll even go through some of these other ones. I'll actually, because I've already done 16 and 17 on the previous review, I'm going to go ahead and I'm going to do number 20. And let's see if there's another. It's pretty straightforward. I'm going to do number 20 instead of 16, but what I'll show you, you should be able to set it up the same way and you'll understand that. I'll still do 17 just because that's a good one to do. But before I do any of that, I'm going to just kind of discuss the important stuff about flow rates. So flow rate just means some volume over some time. Okay. Now, in a clinical setting, nursing setting, when we refer to volume over time, what we're programming into our infusion pump is milliliters per hour. Sometimes you'll see it written as cc's per hour, but it's the same thing. Then a subset of a flow rate is called a drop rate. And that's going to be written in drops. So that's GTT per minute. So flow rate is just a volume over time. Typically, it's milliliters per hour. I had someone ask me in a previous review session, their answer was in milliliters per minute. Was that okay to answer? And I'd said, no, it's not okay to answer milliliters per minute because the standard and what you would see on an infusion pump next to the patient's bed with their IVs connected to, it's going to be in milliliters per hour. Next semester, when you get into the 3rd semester, you'll be introduced to units per hour and then converting that to milliliters per hour. And that can add some grief, but I think if you should be able to do it once you learn a few of these tips here. All right, so as a basic just example, let's say you had, we want to know what to program the infusion pump if we want to infuse, let's just say 1.5 liters of something. Okay, so it could be normal saline, it could be dextrose 5% or 5% dextrose in water, whatever you are ordered to diffuse. We could be doing any number of things, and it's supposed to infuse at, let's just say 400 or 100. I'm sorry, 1.5 liters to infuse over a period of, let's just say 4 hours. Okay. So I'm making this up. Okay. It's just making up this thing. And then the question is, what do you program into the infusion pump? Because sometimes, especially on like ATI, it won't tell you what your units are. But because I told you what your units are, it's going to be milliliters per hour is what we're looking for. So first thing is I need to convert 1.5 liters to milliliters. And then I'm going to divide by the number of hours. Now I'm in milliliters per hour, and all I need to do is reduce that. So I had my phone here a minute ago, but I'm going to pull up my calculator. So I'm going to get 1,500 divided by 4. That is 375 milliliters per hour. There's no additional math to do with this. This could even tell me that it's 1.5 liters of a solution that contains 450 milligrams of a medication. That doesn't matter, because what we want and what we're concerned about and what we're looking for is the rate, volume over time, milliliters per hour, when we're talking about clinically. When we get into drop rate, there's some additional information that we need to know in order to do drop rate. So in order to calculate a drop rate, I need to know the flow rate. I need to know something known as a drop factor, and that will give me my drop rate. Flow rate, as you already know, is in milliliters per hour. Sometimes it's in milliliters per minute. Drop factor is drops per milliliter. This is usually given to you, or there's a picture of it on the label, and I'll show you the example in just a moment. If it's not given to you and they mention microtubing, what they're referring to with microtubing is 60 drops per milliliter, and that would be a known. So at the Allegheny campus, I haven't seen questions where they expect you to know the microtubing, but at some of the other campuses, Boyce, North, South, they may mention microtubing, they may mention a drop rate, and you need to know to use that number 60. And then that will equal your drops per minute, which tells you you need to convert hours to minutes. But if it's already in minutes, leave it in minutes. So let's pull up that sample problem number 20. And then you should be able to answer 16 as a result of that. And then I'll show you again what to do with number 17. So for number 20, this question seems a little bit wordy, I know. Let's go back to it so we can see it together. So number 20 says the physician ordered 1440 cc's of dextrose 5% normal saline to be infused over 12 hours. If your tubing is labeled as below, what will the flow rate be in drops per minute? So the important information that we need to know is our total volume, the 1440 cc's. We need to know that it's infusing over 12 hours. We need to know, because we're going and we're looking for a drop rate, we need to know the drop factor. And that's what's written there on the picture there. It says 10 drops, approximately 1 milliliter. So that's what you'd be looking for. That's usually pretty straightforward. It'll be a picture of a label with a big number on it. That one says 10. This one says 15. Sometimes they say 20, 30, 60. There could be any number of variations of that. So that's the details that we need to know in order to answer this question. And it's the same details you would need to know to answer 16. You would need to know the volume, the time, and then the drop factor. Okay. The difference with 16 and versus what I'm going to show you now is this is already in milliliters per minute. So you just leave it alone. 75 over 25 times 15. And that is your answer for that question. But let me work out number 20 so you can see what that looks like. Okay. So as I mentioned before, in order to calculate the drop rate, I need to know my flow rate. I need to know my drop factor. And once I have those two pieces of information, I can calculate my drop rate, which is my drops per minute. So we start off with our flow rate. We have a total of 1440 cc's infusing over 12 hours. We need to reduce this. And there's a couple ways you can do this. And I'm going to show you the different ways. So the straightforward way is this. I would reduce this to, I would take 1440 divided by 12. And I would get 120 cc's per hour. Then, if it were me, I would just convert and change where it says hour, and I would make that minutes. Then I would just multiply by the drop factor of 10 drops per milliliter. We know that cc's and milliliters are equivalent, so we can cancel those out. And then I would multiply across the top, divide by 60, and I'm going to get 20 drops per minute. An alternative way to setting this problem up is I would just right off the bat take my 1440 cc's, and then I would multiply 12 times 60, and that would give me 720 minutes. So I would before I even write anything, I would just kind of set that up like that, multiply by the 10, and I'm going to come up with the same answer. This was just kind of in steps. This is maybe one less step. And you'll still get the same answer, 20 drops per minute.
So you multiply what's on top first, right? You said?
Yes.
And then you divide it.
Mm-hmm. Now you can, like when I do this in my head, 1440 over 720 is 2 times 10. You can do it that way if you want as well. But typically for simplification purposes, multiply across the top and then divide by whatever's in the bottom. And I will say the challenge with drop rates is you really can't do the ordered over half setup with those. You might be able to maneuver that, but ultimately what I'm doing in my head is I'm just putting, I need time in the bottom. I need my and I need my drops in the top, and then I'm just kind of arranging it based off of that. But if you ever get stuck, this is the proper procedure for that. Now, another question that's similar to 17, I'm going to make one up because this is where people get like, or nursing students get hung up on what to do. And when you have something like something's infusing, like let's say 200 milliliters is infusing over 45 minutes. And they ask you, what is the flow rate? Usually they're going to tell you milliliters per, or to calculate milliliters per hour, so that they don't. When they ask for you to calculate the infusion rate or the flow rate, if they don't give you a drop factor, you have to assume that you are calculate, or they don't mention anything about tubing or microtubing, you have to assume that they want it in milliliters per hour. So there's two ways to set this up. And this is very similar to question 17. 200 milliliters, 45 minutes. And then I would just convert minutes to hours. I know there's a number of you that are hesitant to do dimensional analysis or don't really care to do dimensional analysis. One of the main reasons I always show that is because oftentimes what is usually missed is you forget to multiply or divide by 60, and then you kind of guess and you have a 50-50 shot of getting the answer right or wrong. If for some reason like that's a sticking point for you and you're wondering like, okay, I got two numbers, how do I differentiate, or how do I determine which one's which? One of the things that can help you out is just kind of rationalize. If 200 milliliters diffused over 45 minutes, your milliliters per hour should be higher than 200. So that would be a good indication. So if you get two numbers, and I'll show you what I mean. If you kind of are like, I kind of get the flow rate thing. I don't like doing dimensional analysis. And then I always get two numbers. How do I know which one to choose? Look at what you're comparing it to. If you infuse 200 milliliters in 45 minutes, that means if that infusion was continuing on beyond 45 minutes for another 15 minutes, it's going to be more than 200 milliliters, rationally speaking. Like what probably makes more sense to you is if I said 200 milliliters in a half an hour, then that would mean in an hour, if it kept going, that would be 400 milliliters because we would double that amount. So it's a similar principle. So if you ever get stuck and you hate doing dimensional analysis, that'd be one way to do this. So what I'm going to do is I'm going to take my 200 times 60, and then I'm going to divide by the 45, and I'm going to get a decimal answer. I'm going to get a 266.6666 repeating. And then what we're going to do is we're just going to round that to 266.7 milliliters per hour. So if you get a flow rate type question and on the test and it has a decimal answer, if it's a number greater than 1, round to the nearest tenth. In reality, you may not be able to program 0.7 into the infusion pump, but this is this is just a math test, so it's not exactly reality, but you'll kind of get experience with that when you are doing those clinicals and you're setting those infusion rates. They just want to make sure you can calculate or at least do the math to get to that calculation.
Wait, so sorry.
Go ahead.
So on the exam, they're going to want us to leave this in decimal form, is what you're saying?
They want you to round it to the nearest tenth.
Okay, and there will be like instructions on there reminding us to round to the nearest tenth, or we just assume that that's what they want?
You need to know that because I don't know if that's told to you or when that's told to you, but you need to know to round to the nearest tenth.
Okay.
Yeah, I don't know when that's explicit, but to my knowledge, it's not on your test. You're just supposed, you are either, obviously attending the review, that, or you should already know that. I don't know at what point you were told to know that, but now you know.
Yeah, I'm coming in late. I'm in the LPN to RN bridge, and my previous school was like very adamant about never rounding to the nearest tenth because in the pumps you can't program the decimal. So I'm glad that you told me that because I didn't know.
Okay. No, and I think, and usually what I tell students is write your answers. Like if someone's hand grading, they should be able to see that you did that correctly. And then they may like, it just depends. Like if I were the one grading this, and I would make sure to make that a point, or to answer that question if it was asked. But what they don't want, and I agree with you, because you would probably put what, 267 as your answer.
Yes.
Yeah. So, and that probably is technically the more correct answer, but from what I understand, they want you to go to the nearest 10th for anything, including your infusions. The exclusion to that is your drop rate. Drops, you can't give someone a decimal drop. So you would just round to the nearest whole drop. On some machines, you may be able to program to the decimal. I just don't know. I don't know if that's accurate information or not.
Yeah, usually in the pumps that I use at work, that's not possible, but
Okay.
it makes sense that they just want to see that we can round though. So like you said, it's like book world and real world, like so.
Perfect. Yeah, I always say it's the CCAC math bubble, and then there's reality.
Good point.
Yep, you got it. Oh, I was going to show you guys an alternative way to answer this same question. If you don't know this already, 45 minutes is 3/4 of an hour, which is the same thing as 0.75. And if you're looking at this going like, no, then I'm sorry, that would be an hour. Then you're perfectly fine. But if you ever got to this, if you do what I'm doing right here, the 200 divided by the 0.75, you'll get the same answer, the 266.66 repeating. I should also add that at least what I've seen on previous exams and semesters is like you usually aren't doing any kind of rounding here anyways. It's usually ends up being a whole number. So it usually works out. So it'll be like 270 milliliters per hour. It'll be 265 milliliters per hour. You probably won't have fractional answers, but if you do get one, just make sure you round to the nearest 10th, because that's what they ask you to do. All right. So those were the questions that were asked. Any other questions?
Can you do number 6?
I think we did that one already.
Sorry, I got in late because
That's okay.
my Wi-Fi was down.
All right. So, and not a problem coming in late. And then just so you know, I will post these on YouTube, so they'll be available so you can review this again, but I will also just kind of highlight what I covered. So there's three significant numbers that are associated with these types of questions for number 6. You have what's considered the potential output. So it usually says for every however many milliliters of urine output. So that's the potential. You have the replacement volume. And then you have the actual volume lost. Okay, so the actual, what the patient actually voided. And so what I did is I kind of identified those. So these are the three, all three of these numbers can change. So the replacement volume in one question might be 90 milliliters, and the potential output might be 200 milliliters, and the actual output might be 400 milliliters. They can change, and whatever that is, you just make sure you can identify those. Sometimes the question or the sentence will say, you will replace 40 milliliters via PEG tube for every 125 milliliters lost, and then and in the last 4 hours they lost blah. How it, what is your replacement volume? As long, you just need to be able to identify those things still. So your actual output was the 500 milliliters. The potential output in this question number 6 was 125 milliliters, and the replacement volume was 40 milliliters. I recommend that you follow this formula because it's a little bit more straightforward. If you do ratio proportion, you should be getting to the same answer, but this kind of helps to eliminate that. You just need to remember to put your actual urine output on the top, your potential urine output on the bottom, and then multiply by the replacement volume. So looking at our numbers, 500 milliliters was the actual, what the patient actually voided. The potential replacement volume is the 125 milliliters, and then the potential urine output is 125 milliliters, and then your replacement volume is 40. And then you just multiply, you can, this divided by this times 40, or you can multiply across the top, divide by 125. Either way you do it, you'll get to the same answer of 160 milliliters. Now, sometimes you're going to see this number might actually be less than this. So like, let's say it's at 125 mil for every 125 milliliters lost, replaced with 40, but they only lost 100 milliliters. You would still set this up exactly the same way. You would just be replacing with less than 40 milliliters. Does that help to answer your question, or do you want me to like write it out again? I'm
Yeah, no, that's all good. I get it now. Thank you.
okay. No, you're welcome. And I wasn't saying that to be like, I don't want to write it out again. I'm just asking. If you do, I will. But if you don't need me to, I won't. For the person that asked 21, is that for the 230 or is that for the 130?
No, for 130.
That's for the 130?
Yeah.
Okay. And then 22, I'm assuming is the same. Oh, okay, yeah, because that's your first time seeing the. Oh no, you saw this last semester too. All right, so these are the Allegheny version of reconstitution questions. So for 21 and 22, all right, so for 21, basically you're looking at a label. The label says there are 3 potential concentrations, strengths available. You are, the order is 60 milligrams, and it tells you to choose the strongest concentration. So in order to determine the strongest concentration, we need to look at our 3 options. We have 5 milligrams per milliliter, 10 milligrams per milliliter, and then 20 milligrams per milliliter. The number that's bigger is the strongest concentration because there's more milligrams per milliliter. So you would just, to answer number 21, you would just take your 60 milligrams divided by 20, and that would give you your 3 milliliter answer. For question 22, you're going to do the same thing, except there's some information here that if it's the first time seeing it, you need to know to ignore, and that is this. You do not need to know the milliliters diluent added to answer this question. That just tells you how to prepare. So if you got a question that said, how would you prepare this medication? Or how would you prepare the 500,000 units per milliliter solution? You would add 8.2 milliliters sterile water to the powder, shake it up, and then now it's ready to be used. So now that you know to ignore this column, and as a side note, what you're looking for is if you know a concentration, and the concentration here happens to be units per milliliter. You've seen this written as milligrams per milliliter, grams per milliliter, micrograms per milliliter. Units is just usually how things like heparin, insulin, and I guess in this example, Pfizer pen are designated. So the order is 750,000 units. Intramuscular. Anytime you see intramuscular or IV, you will know that your answer is in milliliters. Okay. Now I didn't ask you here, but if ever just said, choose the strongest concentration and, how much would you administer to the patient? Now, like we can't give the patient capsules, inject capsules, inject powder. It has to be in a fluid state in order for it to be injected via intramuscular, subcutaneous, intravenous. And so if you ever see that, just remember that. So it tells you to choose the strongest concentration. And so we look at our options. We have at 250,000 units per milliliter, 500,000 units per milliliter, and then 1 million units per milliliter. So the strongest would be the 1 million. And the reason I know to choose that is because it tells me to choose the strongest concentration. So I'm going to take my 750,000 units. I'm going to divide it by the 1 million units. And I'm going to get an answer of 0.75 milliliters. And that would be your answer. Now, what might be helpful, and I posted these in the Google Drive folder as well, just kind of different pictures of some of these things. And then I'm going to show you the Pfizer pen, what the actual label looks like. So this is what the Pfizer pen label looks like. It'll tell you, 1 million units, but what does that mean to you? Like if you're trying to calculate how many milliliters to administer, how do you figure that out? Well, you have to look at the label itself. And so I'm going to zoom in here. We can look at the label here, and it says, and I know this is on its side, it says the usual dosage is for intramuscular injection is 200,000 to 400,000 units. So that 750,000 units is probably too much. Then it tells you how to make the different concentrations. For this one, 50,000, 100,000, 250,000, and 500,000 units per milliliter. These right here just tell the pharmacy, or if you happen to be the person adding the sterile water to this, how much sterile water to add. For a stronger concentration, you add less water. For a weaker concentration, you add more water. You make it more dilute. And so depending on the order and what you're told to use, that's what this kind of label looks like. Okay. If you're at one of the other campuses, like at Boyce, go to the next image. Nope. Okay. Let me do this real quick. If you're at one of the other, like if you're at like Boyce or something, there are let me show you this one. So for this one, this is the ampicillin. It tells you that it's 1 gram of ampicillin, but what do I do with that? You need to look at the label to figure out what to do. So it says for intramuscular use, you're going to add 3.5 milliliters of diluent. And then that's going to give you a resulting solution of 250 milligrams per milliliter. Okay. So now that you know that there's 250 milligrams per milliliter, that is the number you would use to figure out how many milliliters to give. So if the order was, 300 milligrams IM BID for ampicillin, and then you had this label, you would have to look at and see. You don't need to worry about the 3.5 milliliters. You're just looking for this piece of information right here. Let me just highlight that so it'll be helpful. You're looking for this, the 250 milligrams per ml. That's usually what you would see on like the Dilantin question or the amoxicillin. You would typically see that written right there. But some of these reconstitution questions, you have to investigate the label a little bit more. So knowing that it's 250 milligrams per milliliter, then you would take the order I said was 300 divided by 250, and then you would administer that many milliliters. And I know some of you are like, what is it? So let me do that real quick. So 300 divided by 250 would be, you would administer 1.2 milliliters ampicillin via intramuscular injection for that scenario that I gave you. All right. Okay. I have probably time for one more question before the next session starts. And then I am meeting with your class again at this afternoon at like 3:45. So let's see. Let me pull up number 15 real quick.
I just have a couple of questions about the instructions because I find them to be a little bit confusing with like them asking about the different arrows, and I just want to make sure I'm understanding it right. So I can like explain what I did, if that's okay.
Sure.
Okay, so it says indicate the solution to be drawn up first. So if we are looking at the insulin, you always draw up regular insulin first. So I just drew an arrow to the bottom B syringe to the 10, and I put regular insulin first. And then I drew my second arrow to 40 units. And then I just put NPH second. And I'm assuming that that's what they mean by the correct total medication levels. Did I think about that right?
Sorry about I was listening to you, but I had to step away because there was a spotted lantern fly that I needed to kill. Sorry.
That's okay.
I don't know if you guys know that we're supposed to kill those things. So anyways. So I'm going to show you, this is from the text, one of the textbooks that we use for identifying and reviewing. Let me just see here. Hold on. It's loading up. On how to do this, the insulin syringes. So because they're a little bit confusing. So this is a similar example where they tell you 10 units regular, 30 units of Humulin N, and then your example was NPH and it was 40 units, and it says to mark the syringe. The correct way to mark to the syringe is, first of all, when they say the total, it's the total. So you would make your first arrow, or an arrow should be at the total amount. So in the example on the test, it would be 50 units. This example, it's 40 units. Okay, so that would be the total. Notice where they mark the 10 units. It's between the total and where the Humulin N is. And so from what I understand and what you are supposed to, or how you're supposed to mark the syringe, if they even ask this question anymore, is they want you to mark the regular in this range here. Yes, you drew it up first and you're still going to indicate regular first. And I'll show you in just a moment how I would answer this question and how I would mark it. But they want you to draw that initial, your marks would basically be at an arrow at the total amount and then an arrow 10 units less from that total amount. So in a hypothetical situation, because you drew the 10 units up first, and then you drew the 30 units or the 40 units up second, you would think that the 10 units would be closer to what I call the plunger end of the syringe. In reality, and I've watched several videos of this, when you draw up the insulin, it all mixes in together because we're not in a physics lab where we can remove and create a vacuum environment in order to keep the liquids separate. We just can't do that. So how would I answer this question? And hopefully it'll give you some clarity on how you're asking it. And are you the same student that is an LPN?
I am, yeah. So
Okay.
that I was trying to just figure out, like, in the real world, the way that you just explained it is what happens, right? Like the syringe fills up past a certain point, further than what you would think, because you're putting two medications together. But I didn't know, like, if this question was trying to trick anyone to, like, I don't know. I just, what you said made sense. I
Okay.
would do it that way, but I just wanted to make sure.
Yeah, no, and this is a commonly missed question just because of the semantics of it, because I feel like it's not even math. This is more like practicing marking on a syringe. So if I were answering this question, I would say, I would like on this bullet point, I would say 10 units regular, first. Pardon my abbreviations here, but I would say that I would draw up 10 units regular first. Okay. And then even though it says where to, it wants you to mark 2 arrows, I would make sure to mark solution B. I would take the total amount, which is 10 plus 40, which is 50. And I would make a mark indicating that this was the total amount. So I'm just going to write T. Okay. So total, you can say regular plus NPH. And then in order to be compliant with the image that I showed you previously, that would be, I make my second arrow here. And then I would indicate that my regular was in this 10 unit frame. And then that I would even make an additional indication that this is where the NPH was located in this area here. I'll just write it N. So I would actually add extra marks to the syringe just to make sure that my instructor knew that I knew exactly where they, what they were asking for. This question has been around for a while, and I'm actually surprised that it's still asked. I think it's important to know, like, when you look at the syringe, that it's in increments of 2, so 20, 22, 24, 26, 28, 30. So you would, be careful with marking that. But this is always a point of contention type of question that I always say, like, the best thing you can do is just ask your instructor how they want you to mark it and then do it like they say to do it. But the textbook says that way. What you explained to me is how I initially would explain. I would say you would mark at 10 because that's what you would draw up first. So step 1, 10, and then mark it at total 50 and then go from there. But over the years, students had missed this question because I think this is what they're looking for, more of you being able to break down where it would be when you would draw it up. I don't know if I answered your question, but that's how I would answer this question. And I would obviously draw it better than I can with my mouse.
No, yeah, you answered my question. I just wanted to make sure that, like, they were looking at it as the whole problem and not like step 1, step 2 sort of thing.
Yeah, no, and I personally look at it step 1, step 2, because it's, and then how do you demonstrate, but in reality, like you said, and I think you actually clarified that even more. So for me is at the end of everything, where would hypothetically everything be?
Right. Okay. Thank you so much.
You're welcome.
Last question real quick. You said that for 130 there's some questions that are on here that like wouldn't be on our test. Right?
I don't,
Or you
not
said
on
that some
this.
questions not on this.
No, on this you will see, you'll see it. This is a mirror of what you would see on your test. I would say maybe these last 2 questions, potentially you may or may not see, but that I would say 24 and 25. But I would say for the most part, when I created this practice test, it was based off of like an actual test. So,
All right, thank you.
you're welcome. All right, guys. So for the 130 class, like I said, I'll be back around 3:45. And then if you are here early for the 220 to 30 class, we'll start up at 1:15.
Thank you.
You're welcome.